This is 151 of these animals that's died on this farm up here since this stuff has been coming down through this water.
Alright, welcome back everyone. This week I wanted to talk about deriving circular motion equations using calculus. So I want to remind you that the arc length s subtended by the angle theta is equivalent to the radius of the circle times the angle subtended. So we're going to be using s equals r theta to get started. So we'll start by taking a look at velocity in its differential form, which is ds over dt, where s is the arc length. So you substitute in r theta, so you have d over dt times r theta. And the r is a constant, so you can bring that out of the differential. So you're just left with r times d theta over dt. So here it's important to talk about angular velocity, also known as omega. And there's a few different definitions. So omega is 2 pi over the period of the rotation. And then we know that frequency is defined as 1 over the period. So you can rewrite omega as 2 pi times the frequency. And then this is also known as d theta over dt, the change in angle per unit time. So what we can do is substitute omega in. So v equals r times omega. Now we'll move on to the second equation, which is going to be about acceleration. So you have the definition of acceleration, which is the change in velocity over the change in time, so dv over dt. And we can use a little trick here where we multiply by a 1. In this case is d theta over d theta. And then you can just rearrange this to dv over d theta times d theta over dt. So those are equivalent statements. And then remember that v equals r times omega, which is also d theta over dt. So we could solve that for d theta over dt, which is just v over r, and then plug that in. So we have dv over d theta times v over r. And now at this point we know a couple different things about this differential. With dv, that's just the velocity that's accumulated over the change in rotation. So that's just going to be 2 pi times v. And then we know that the change in angle for one rotation is going to be 2 pi. And that's all times v over r. So the 2 pi's divide out, and we have v squared over r. And then what we can do is plug in that v equals r omega. So centripetal acceleration equals r omega quantity squared over r, which is r squared omega squared over r. 1r divides out the r squared, so we're left with r omega squared for the acceleration. For the third equation, we're going to do force, which is going to be a pretty quick one. So the centripetal force equals the mass of the object times the centripetal acceleration on it. So we can just substitute in r omega squared, and we have our equation. For equation 4, I thought it'd be interesting to look at the gravitational force. So we can actually use that last equation here in a second. So gravitational force is the gravitational constant g times the mass of the larger object times the mass of the smaller object divided by the square of the distance between the two. And now we know that Fc equals mr omega squared. So we can plug that in on the left side of the equation. So we have mr omega squared equals g m times n divided by r squared. So the little m's divide out, and we're going to isolate the omega squared. So we have omega squared equals gm over r cubed. And now at this point, let's remember that omega equals 2 pi over t. So we can plug that in for omega. So 2 pi over t, quantity squared equals gm over r cubed, up with 4 pi squared over t squared equals gm over r cubed. And here we want to isolate t squared. Remember, t is the period of oscillation. So we're going to have 1 over t squared equals gm divided by 4 pi squared times r cubed. We just divided the 4 pi squared over. And now we can flip both sides of this equation. We got t squared equals 4 pi squared r cubed over gm. So I wanted to explain a little bit more about this equation. So it's written in terms of the period of oscillation as a function of the distance between the two objects, because 4 pi squared over gm are all just constants. So we have the period as a function of r. And I think it's just easier to look at a situation like that in this way.